Sorry about the little delay there. Hopefully you can hear me. So I'm gonna see. Can you just send me a thumbs up if anybody is listening? There was just a little bit of problems there with my sound. And I've been having one of those days, to be honest. If anybody knows how you can fix squeaky shoes, I've had exams this morning and walking up and down through exam halls with my shoes squeaking. So you're lucky that you don't have to listen to me squeaking. All right, thanks a million, guys, for letting me know that it's all good. So we'll get started today. Apologies for the lateness in our start today. As I said, we had exams this morning, so it's been rush, but we'll get going and we'll get through everything that we want to get through today. So let's have a look and see where we're doing. So we're on to topic 5, week 5 already. So you're after staying with us for the first 4 weeks. So that's great. So we'll have a look and just see what we have done in the first 4 weeks. So before reading week, which really wasn't a week off for you at all. It was an assignment week, but you know, that's the way things are. So before that, we had done sequence, selection and iteration. So we had a look at the real fundamentals of every programming language, how code runs from top to bottom, one line after another, how we can introduce selection, and we looked at the if statements and how we have, we can go down different routes based on what we called our Boolean condition. So we had our if statements. And then we looked at iteration, and we looked at our for loops, our while loops and our do while loops. And we said iteration makes the code do itself over and over again. So we're repeating a block of code for a predefined number of times or until something occurs. So we had a look at iteration. We looked at strings and how strings are a class and how we use them in our code, and how strings, the nice people who wrote the class strings for us, included lots of methods that allow us to do things with strings, to get a substring, to make the string upperclass, to make uppercase, not upperclass, sorry, uppercase. Upperclass is a whole different thing. Uppercase or lowercase. So we had a look at strings. We started in arrays just before we finished up, and how we said instead of having numerous variables, we had one space in memory that was broken into a number of compartments or elements, and we accessed each element through an index. And we likened that to our terraced houses, and how our terraced houses had a number on it, their door, and that's how we accessed it. That's how we knew we wanted that house. And that's what we did with our arrays. So we did those. We looked at methods, and how methods are a little worker bee for us. We give them information or not, and it may return something to us or not. So a method was a block of code that does something for us, and we can call it over and over again. We looked at the scanner class, and we said that the scanner class is our initial attempts of taking information in from the user. So that's what we're going to use the scanner class for. We're taking the information from the user. So we're telling it that we're using system.in, which is our keyboard. There are other ways to use the scanner class. We could use with files, etc. We're not doing that at the moment. So we looked at using the scanner class, creating a scanner object, and telling it that that scanner object was going to use the keyboard as its way of taking information in. And finally, amongst many other things that we did before reading week, you also did your assignment. So I'd like to congratulate everybody on getting it in. Well done. A few of you have still had come back for various reasons, so we'll have a chat with you today. But I want to say that it's really hard when you start back into education. The first assignment is so hard. It's so hard to figure out how much is expected, how you actually go about doing it, what steps. And I just want to say, it's really heartening when you look at Slack and you see how each of you are helping each other. So before myself, Mairead or Pete get to answer a question, you've already answered it in a lot of cases. And we always check to make sure that the answers that are being given are quality answers, and they are. So it's really great. So if anybody has any questions about the assignment, give us a shout. It's in now, and we will be looking at giving you your marks over the next couple of weeks. There is a part on it where we ask for an interview, and we may, interview 1 or 2 or 3 or 4 or 5 or 6 of you. We'll let you know very soon if we're going to interview you. Okay, so congratulations, that's it done, and we'll move on this week and we'll see what we're going to do this week. So today we're going to have a look at classes and objects. So for the last few weeks you have been using classes and you have been creating objects. Today we're going to delve a little bit deeper into what a class is and what an object is. So even though you've been using it, we're just going to go a little deeper into why you've been using it. Okay, so we're going to talk about the properties. So the fields is what we're going to call them, or instance variables, or attributes of our class, and our methods. So we've already seen methods and we've already seen methods in classes, but now we're going to just take a little bit step further in our understanding of what we're doing. So today we're going to have a look at classes, objects, the properties of those, and the very important dot operator. Okay. And by the end of it, we're going to create our first class, which is going to be our bank account, which is great because my bank account is fairly empty at the moment, so hopefully yours is better than mine. So we're going to create the code for a bank account, and we'll move on Wednesday and we'll keep adding to this bank account on Wednesday. So without further ado, let's get going, and we'll see where the day takes us. Okay. So classes and objects. So as I said at the start, up until now, we've been using a very procedural approach to our coding, and we have done that because we want you to learn the basics of programming, our selection, our iteration, what our variables are, what the data types are. So we've done it in quite a procedural way. We have introduced classes, so you've been using the driver class as our main hub. And we have been, which kind of has been doing quite a lot. It's been reading the input, it's been doing little jobs. And then we have introduced another class with some methods in it that we've been calling upon to do to do some work for us. And in your assignment, you did that. You had your driver class, and then you had your car helper class. So that's the way we've been kind of coding up to now, and it's a great place to start because it gets you started without really having to fully understand the whole idea of classes and objects. It teaches you the basic of the logic, the flow of control, and methods. But really, it's not how software is structured in the real world. Real systems, like even small ones, quickly kind of outgrow the procedural approach. So one class is kind of too complex, or 1 or 2 classes is too complex for your whole project. So I suppose if you imagine a company, and if your organization, and one person was doing everything in that organization, the financial controlling, the marketing, the packaging, the talking to the customers, the relationship with our customers and our suppliers, etc., etc. If one person was doing everything, you kind of see how chaotic that could become after a while. And that's kind of like what we've been doing at the moment. We've been, getting 1 class or 2 classes to do everything. So now we're kind of going to slightly change our mindset. And instead of writing programs that are just a series of steps, we're going to start thinking in terms of objects. And that's pieces of code that represent real things or concepts in our system. So we're going to start thinking in terms of objects in our code. And so object-oriented programming, or OOP, where you might see it mentioned, is all about building programs out of objects and getting them to take care of themselves. So we've seen in our introduction there that we said that we're going to have a class, and our class is going to have attributes. So that's the information about the object, and it's it's what it knows, okay? So it's the data. And then our class is also going to have methods, and that's what our class can do. So it's the behavior of the class. It's what the class knows. It knows what to do. Okay, so we're going to see some examples in a few minutes, and we're going to see. I think we have our car example and our book example. So we'll have a look at those, and we'll have a look at how we're going to program those. Okay, so without further ado, let's get started, and we'll get started on our classes and our objects. So what is a class? So a class defines a group of related methods and fields. So variables and properties. So we talked about separation of concerns and making sure we write our code so it knows it's self-contained and it knows what it's going to do. So our class, it defines a group of related methods. So into our class, we're going to write a space for all of the data that the class needs to know about, and we're going to put all of the methods that maybe act on that data or do something for that class. Okay. So here we can see that we have our class string, and we saw that the last day we were looking at the string class. And if we go into our Java docs, so into Oracle, you will see that we have our class, and we have all of the methods that belong to that class. So these are all of the action items or the behaviors of the class. An object is a single instance of that class. So we create an object from the class. Okay, so it's very powerful, because it means from one class we can create many objects. So if string is the class, so remember we said that string was a class, some nice person wrote it for us, and it comes with lots of methods that make our life easier. So in this case here, string is our class, and we're going to create an object, and we can create many objects of type string. So we create our object, it's called A, and into that we're going to put a value. In this case, we're going to say hello. So A is the object which contains the string hello. Okay, so when we talk about our attributes, in this case, our attributes or the data is hello, and that class string comes with lots of different methods, and we looked at char at, we may have looked at toUpperCase, and they are the behaviors that can affect the data, or that we can use to change that data, or to what we're going to do. Okay, so we create an object called A, and it stores the data, it stores the value hello. So when we think of classes, we want to think of a class as being like a blueprint. So there's lots of analogies that we look at when we're talking about classes. Again, one of these analogies will make more sense to you. So I like to think of a class as being like the blueprint for the building. So it's the plan for the building. In the class, we define what information we're going to store. So what the data is going to be. So the size, the square footage, the number of rooms, the colour of the front door. So these are all going to be the data that we're going to store about our class. Okay, so it's like the blueprint for a building. And then when we create our object, that's when we construct it. So the object is the actual building that's constructed from that blueprint. So if you think of it, if you look at any of the housing estates that are being built around, we will see a few different plans for the houses, but each plan can have many houses built from it. But they may have slight differences. The front door might be slightly different. The colour of the windows might be slightly different. And that means that that's the attributes for that object may be different, but they have the same attributes. So they have the same square footage. The field is the square footage. The field is the door colour, but the value may be slightly different. Okay, so in house number 1, the door colour may be blue. In house number 2, the door colour may be red. Each object has its own value for the attribute. Okay, so you can build lots of buildings or objects from a single blueprint. The car analogy. So in our car analogy, a class is like the general template of a car. So again, it's the design of the car. From that design, you can have many different cars being built. So you can have a blue car, a red car, a white car, whatever it is. So the object is the car that's based on that template. And remember, and we'll come back to it again, you must create the object to be able to interact with it. So to be able to drive the car must exist. To be able to live in the house must be built, must exist. So when we create the plan or the class, that's just it. It's the plan. Until we create the instance or the object, it doesn't exist. Okay? And that will make a lot of sense when you're going to try and interact with objects. Until the object exists, you can't do something with it. Okay, so until that nice yellow, I'm going to say it's a Morris Minor, but I don't think it is. I'm not quite sure what it is. So maybe it's, anybody who knows what that car is, I'm sure Mairead does, can tell us. So you can make lots of cars, objects from our single class, from our single template. So again, we can make our fancy, I know that's a BMW, and the next one definitely is a Morris Minor, and then whatever the yellow one is. So you can make lots of cars, objects from a single template. So many objects can be constructed from a single class definition. So we define the information that we want to store. We give our class a name. We just define the behaviors of that class, what that class can do. And then from a single class definition, we create many objects. Each object must have a unique name within the program. And you've seen that already. So when you're creating, we'll go back to what you know. So when you are creating a string, we said string and we gave it a name. Just gonna make this a little bit skinnier, sorry. And if we wanted to create another object, so now in memory, we have A pointing to the space in memory that has hello, and we have B pointing to the space in memory that has goodbye. Okay, I'll have to see, can I figure out how to make the writing, make the pen a little less thick. So what we're saying there is from the string class, because that's what the string class is, we've created two objects. Each object has a different value, so the data is different, but we can then interact with those by calling upon that object. And we're going to learn how to do that in a little while. So we need to be able to access each of the objects. So like we want to be able to access each of our string objects, we need to be able to access each of our objects. Okay. So that's when we have our properties. So remember what we said about our properties. Our fields are the information or the data, and our methods are going to be the behavior. And we said in Java we call, in other languages we might call them a function, we call everything in Java a method. So objects are typically related to real world artifacts. So in object-oriented programming, you model an object by grouping together the related methods, the fields. Okay, so let's say, for example, and we're going to go on to an apple in a second. Let's say, for example, you are asked to write a program for a library. And again, we do have this in our notes, but we'll come back to it in a second. And you say, well, in our library, we're going to have a book. Okay, so you'd say we're going to have, oops. Okay, for a sec. We're going to have a class, we're going to need to create book objects. So if we know going to need to create book objects, that means that we're going to need to create a book class. And into our book class, we'll write the information that we need to store about the book. So we might need to store the ISBN for the book. We might need to store the cost of the book. We might need to store the title of the book. We might need to store the number of pages for the book. Okay, so these are all the information that we might want to store, and they're going to be, all of this is going to be our fields. And we've been calling them up until now, we've been using variables. And in our classes, we call them instance variables or fields. So they're the data that we want to store about an object. Okay, so that's our fields. We also might want to know what methods. So what can the book do? So what are its action items in the library? Okay, so we might be able to borrow the book. Oh, and would help if I could spell properly. We might be able to return the book, etc., etc. So these are all the methods. So they're all the action items or the behaviors of our book. So when we think of the real world artifact that we want to model, we think of the name that we're going to call this real world artifact. We think of the information we're going to store about that real world artifact, and we think about the things that it can do. Okay, and we're going to see other examples now in a second. In an apple or a fruit, whatever it is. But basically, when we start to program from now on, we're going to be using everything that we've learned so far, except we're going to be thinking about how we're going to model our classes. So each part of our system is going to be responsible for its own data and behavior. And we can make the pieces interact just like real objects interact with each other. So our driver class from now on will be the same, or we can call it driver, it's just a name, or main, or controller. Okay, it's going to be like the person at the front desk in a hotel, setting things up, asking for a user for input, and then telling the objects what to do. But the actual work, the logic, will happen inside of these objects that we're going to create. So instead of thinking that we're solving code, instead of asking, I suppose, from now on, what steps do I need to take to get this done, which is what we've been kind of doing up until now, we're going to start asking what objects are involved, what do they need to know, and what can they do. So what do they need to know? So what's the data? So what's the information that needs to be stored, and what can they do? So what's their behaviors? So what are the related methods? So when we now think of a piece of code, we're going to think about all of the objects that are going to work together. So I suppose one way of thinking about it, like we see it everywhere. Every app on your phone, every website, every back-end system, they're all built on classes and objects interacting with one another. It's just how we manage complexity in modern software, by breaking problems down into smaller, self-contained, cooperating parts. And that's what we're doing. We're creating self-contained units of code. So we're moving this week from code writers who tell the code or tell the programmer exactly what to do, to becoming software designers. So that's when we model systems, we define the relationships, and we make the computer look a lot more like how the real world looks, I suppose. Okay. So our object example. So our class is going to be Apple. So when we go to, I shop in Lidl now, I don't know where you shop, but when you go into your fruit and veg department, you'll see lots of different apples. They all have the same feels. So they have a colour, they have a weight, they might have an acidity, I don't know, but they have the same information that needs to be stored. Each brand of apple might have a slightly different colour, might have a slightly different weight. Okay, so they're the objects. So each object is our apple. It has its colour, it has its weight. That apple can grow, that apple can fall, and that apple can rot. So the methods are the behaviours of the object. Okay. So we have our butterfly. Again, when you think of your butterfly, you think of what information do I need to store about my butterfly? So what do I need to store? So you're saying I might need to store the species of my butterfly. I might need to store the gender of my butterfly. So each butterfly object that we create will have its own value for species and its own value for gender. And then that object, it can grow, it can flap wings, and it can land. So these are the behaviors of that object. So we write the code once, and then we can create many objects from that class. So again, real world example, it's a radio. It has a frequency, a volume. So what frequency is it set? Each radio might have a different frequency that it's set to. It has a different volume. So when we start off, if we had two radios, we might have one radio, its sound at 1, and another radio, its sound at 10. So each radio, each object will have its own values for these fields. And then we can turn it on. When we turn on, we're turning on the one radio we want to turn on, that one object. When we tune, we're changing the frequency, we're tuning the one object. And when we set the volume, we're setting it on the one object. So again, this is what we do the whole time. We have, in a classroom of students, we have a student class. Each student has a name, an address, a student ID, a class that they're belonging to, the group that they're belonging to. Each students, they have a number of methods that are associated with behaviour. And when we want to interact with that object, we have to interact with the particular object. So if we want to change a name, we're changing a name on an object. So changing the surname from Power to Roach. We're not changing everybody's, we're just changing that one object that we need to change. And it's the same with our radio. We create our class, we create the information that's going to be stored, we create the methods that are going to be able to be invoked, and then we create the objects. Okay. So again, we have our car, and we can have many cars. Each car will have its own make, its own model, its own year, its colour and its own year. And then if we want, we can call the method change colour on one of those objects, and it will change the colour on one of those. So from now on, when we're modelling our real world environments or our real world objects, we're thinking, what's the name, what's the data that it can store, and what are the action items, what are the verbs, what are the behaviours of this, and they're your methods. Okay, so we can have a look at many different, you'll see in your exercises, there's other ones that we've had a look at, but when we're thinking about how we're modelling things from now on, I want you just to always think, this is how real world modelling, we do it in the real world. We specify, we classify things, and then we design them. So if we're designing a dress or whatever it is, the dress will have a hole for the neck, it'll have holes for the arms, but each dress, each object that's created from that class can be slightly different. Different hemline, different colour, different sparkly things are not on the dress. So each object is different, but the data, the information that we're going to store is the same for each, but the values are different. Okay. So returning to our apple, we had our apple, and we said that our apple had a colour and a weight, and the methods were grow, fall and rot. So this here is going to be our object type, so that's going to be our class name. The fields are going to be the data. So that's going to be the properties or the attributes, and the behaviours are our methods. Okay. So when if we were creating greengrocers and we were creating a class called Apple, we would decide if we had our apple, so if we had our apple, I'm really wasted, I should have been an artist. Our apple is going to have a colour, and it's going to have a weight. It might have, you don't call a fruit a species, like, I can't think what you call it. It's like a gala or, apple. I'm sure it's on the next slide anyway. So it has like a type, etc. So these are all the information that we're going to store. These are our fields. And then that apple can grow, it can fall, it can rot, and it's going to be its behaviours. So this is how we start by modelling it. We design what we need to do, what information we need to store, and what are the methods. So to make a blueprint of an apple, so to create our class, we're going to have the name, so we're going to have our name, so that's going to be our class name. These are going to be our fields, and these are going to be our methods. I'll just take that actually and call it methods. And these are going to be our methods. So the grow method, when we go to make something grow, it might have inputs or parameters for temperature and moisture. We can increase the weight field of the apple based on these inputs. So again, when we're going to design our class, we'll think, what are the fields? What's going to be the data type for those? What are our methods it can grow? Does our grow method need information to do its job? So how will it work? So again, we're saying that it might have inputs. You might need to tell it, actually, to know how something grows, you need to know what the temperature is where it's growing. What's the daily sun intake for it? What's the moisture content, etc., etc. Any of the farmers that are amongst us will have much better knowledge of what it takes to grow an apple. But based on the inputs will change how big the apple is going to get. Okay, and then that will increase the weight of the apple based on these inputs. The fall method might continually check the weight, and it'll cause the apple to fall to the ground when the weight goes above a threshold. So when the weight goes wherever over 100 grams or whatever it's going to be, it's going to fall to the ground. The rot method could then take over, and it can change the colour field depending on where it is. So once it's after falling, because the weight has gone over a certain weight, then it's going to start rotting. So what does that mean? How do we know that? And that's a question that gets asked the whole time. I understand the apple's going to grow. I understand the apple's going to fall. I understand the apple's going to rot. And again, these are just methods to do with an apple. Any of the information that you need in your methods, how do you know what information it needs? How do you know what the piece of code is going to look like? And how you know is, in the real world, you ask questions. So if you're asked to create an apple class for greengrocers, or sorry, in this case, not greengrocers, for some sort of Voglers, where they grow apples, you would talk to them and you'd say, well, you want your apple to grow, how does it grow? And they'd say, oh, well, we need to know the temperatures. We have sensors in the fields which keeps track of A, B and C. And based on that, you'll need to do A, B and C. So you'll be taking your information from what's given to you. You know, when you become a proper developer, you'll be talking to your customer and you'll be getting the information in, or you'll be using, you know, your documentation that's given to you to find what you need to do to write the code for the methods. So again, depending on what information is given, depends on how you will write this code here. So we said earlier, an object is created from a class. A class can have many objects created from it, and each object must have a unique name within the program. So back to our apple. So if we want to create our apple, that's our class. We might have an object called Gala, and we might have an object called Golden Delicious. And you can see that the Gala object has the colour red and a weight of 6.2. Our Golden Delicious object has colour yellow and a weight of 8.4. So these two objects were created so in memory. We created these two objects. We have an object called Gala and an object called Golden Delicious, and they both have colour and weight, but you can see they both have their own values for that. So they have red for Gala, has red for colour and its weight of 6.2. The Golden Delicious is yellow and its weight is 8.4. They both have methods for grow, fall and rot. So each of those, if I was to say grow, it would be this weight that's going to change for Gala. If I was to say Golden Delicious grow, it would be this weight here that's going to change. So as we start working with objects, you can see the code is self-contained. So we design our object, we design the information it needs to store, we design what it can do, and then we create instances of that object or of that class. So we have two objects of type apple. Each has a unique name. So Gala and Golden Delicious. Each object has a different object state. So what does that mean? It means that the instance variables have different values. So they have their own values. So each object has its own copy of the fields, colour and weight and memory. Each object has its own data stored in these fields. So the blueprint said that there was a field called colour and a field called weight. When we created the instance or the object, so you'll notice that I may change between the word object and the word instance. So the object or instance is the same. Okay, so an instance of a class or an object. So when we create the object, each object will have its own value for colour and its own value for weight. So it has its own data stored in this. Okay. So, as I said before, when we want to access something, we have to be able to know which person, when we're talking about a student in a class, which student do we want to change the name of? So how do you do that? So we do that by using the dot operator. And it's a small but very powerful piece of syntax that we need to understand. It's a little dot between things, and it's how we tell Java, I want to access something that belongs to this object. So it's kind of like saying of in English. So if you wanted to get the colour of the car, it's car.colour. So the fields and methods of an object are accessed with this dot operator. So we can see here it's the object dot whatever the property is, the object dot whatever the method is. So in this case here, we have the Gala was our object name, and the dot is when we're accessing the field called colour. Golden Delicious was our object name, and this little dot here gives us access to the colour of the value that's in Golden Delicious object. So our little dot is telling us that we want the colour of the Gala object. We want the colour of the Golden Delicious object. So when we're talking about fields, it's like saying of. So give me the colour of the Gala object, and that gives access to the colour value in the Gala object. So this dot is our way of accessing values, so the fields and the methods that belong to a particular object that we have created. It's the same for our grow. So if we want to use our dot, we're calling the method grow, and that runs or invokes the method grow inside the Gala object. This guy here, Golden Delicious.fall, it invokes the fall method inside the Golden Delicious object. So this dot is our way of getting information it knows. So we're telling us, give us the information you know about the colour for this object. Okay. As regards method, it says do something it can do. So do whatever this method is for this object. And it's the same. So if you think of it again, you want, you have 3 children at home, Johnny, Jimmy and Joe. And if you want Johnny to clean his room, you don't shout out, clean your room. You say, Johnny, clean your room. If you want Jimmy to wash the dishes, you say, Jimmy, wash the dishes. So you need to be able to identify which object you're talking about. So which object you want to do something or you want a value of. That's how we do it in coding. When we're calling someone to do something, we put their name first. Johnny, wash up. Johnny, do your homework. And it's the same when we're accessing fields in our objects. Object name, dot. So the dot operator is what we're using to access the fields. Okay. So you can see when we have more than one object, you need to be able to access that object, and that's why we're using our dot. Okay, so object name dot field. So it's our object name, and then we're calling, in this case, the field, and this case is our object name, and we're invoking the method. Okay, and this dot here is what allows us to do that. It's our door into into our object is this dot. Okay, so any questions? We're going to come back. I'm going to give you 5 minutes of a break. We'll come back after the 5 minutes and we have an example that we're going to work through, and that'll make it a little bit more, because what we've done now is kind of high level. It's talking about what are classes, what are objects, and it's kind of hard to see what they are until you get your hands dirty, I suppose, a little bit. So I'm going to give you 5 minutes break, and we'll come back in 5 minutes and we'll have an example. Okay.
So just the full mark out of 40, the full mark out of 60.
You don't have to have solutions, do you?
I was looking at that now. I need the solutions. Yeah, I need that. So I'll set
Because I
those
meant to
up.
do it, I was going to do it, and I went, Marie has it done already. I don't want to do it if she has it done.
Absolutely not. Absolutely not. So I actually, would you believe, I nearly had to put it into ChatGPT. This is the things, what are the answers? And I just something else come out.
Oh.
So yes, it's in train.
But I can do it anyway tomorrow morning.
No, it's just a waste of time now. Okay.
Where's Vaughan?
I just got a text from this Maxims. It's been in hospital. Psychiatric.
There you go. Thanks very much.
He was back before an event. Just takes for this in. He missed the exam this morning, which I know was so pleased to God it's not so he said to me, but he's again, so I don't know.
I know she's the same one.
The same one, but I won't tell him that. I told him I have to write it.
There's a guy who contacted me this morning, 7 o'clock. What?
Is he not please remember really what I told him? He's really sick.
I was laughing when I read it. I said, right, nah, you know. But he was just trying to talk to this.
Yeah.
He was like,
Hmm?
chip on his shoulder, and he's walking around. I have no idea. But he came back and kind of walks in me off.
Your thing's up, is it?
I'm on the floor.
Here now. Yeah. Very good, Sean.
I know. See time on it. Right, but I'm going to see what's going on next.
Enjoy.
Thank you very much.
Just no questions coming in.
I wonder why.
But thanks for expecting that I'd know what a Morris Minor was. That's lovely.
There
That's
wasn't a
just
Morris Minor. The Morris Minor was the black one. What was the other one?
As I said to him, Stan, I'm not that old.
Ooh, I did a maraid, did I? Did I do a maraid? Sorry, hopefully now you can hear me. Where are we? Let's go back. And I wouldn't mind, but I was like, I'm after giving you some great advice, but it's after being muted now, so we can't do it. So all I was saying was, yeah, we're going to go and we're going to have a look at an example. I did actually ask if anybody knows anything about squeaky shoes to let me know, which is always good. So we're going to have a look at creating our first class, which is our bank account class. Okay. So we're going to start with sample code that creates a bank account. So our first lot of code that we're going to look at is, we're going to look at how we've done it up until now. So the procedural way, based on the information that we know. So we know at the moment that if we wanted to create a bank account, we'd create a variable that's going to store the amount of money that we want that's in it. We're going to maybe create a variable that keeps our name. And then if we wanted to have many bank accounts, we'd have many variables, one for each of the people who the account is going to be created. So that's going to start with, you know, what we know. And then we're going to move on and how do we refactor that so that we write a class. So we're going to write a class that allow us to group together the data and the methods needed for this functionality. So we're going to start modeling it like we would in a real world. Okay, so this is our sample code, and the bold Elon Musk is our account holder. So if, based on what we know at the moment, if we wanted to create a bank account, we'd create, sorry about this. We'd create a space in memory, and we'd have our name, which is Elon Musk. We'd have a space in memory that says account number. And we'd have our account number in it. And we'd have a space in memory called balance, and that would have our amount in it. Okay, so based on what we know, that's what we would have. So we'd have our three fields. If we wanted to deposit money into it, we'd have a deposit amount. So we're creating a variable called deposit amount, and it has 300 into it. And we're saying the balance is equal to, remember this plus equals, whatever is currently in the balance plus the deposit amount. So it's 1500 plus 300. So that's 1800. So we'll have 1800 in our balance. And if we want to withdraw, we create another variable called withdraw amount. Into that we have 200. And we say if the balance is greater than or equal to withdraw amount, so the balance is 1800, which is greater than or equal to, so we're going to go into this one. We're going to say balance is the same as the balance less the withdrawal amount. So we're going to take 200 from our balance here. Which was 1800, we're taking 200, and that's going to be 1600. And then we're going to print out the name, the account number, and the balance. So if, based on what we know now, if we wanted to create a bank account, we'd be creating something like that in memory. Which is all fair and good. It's going to do the job for us. But what does that mean? Okay, so you can see here that it's going to print out Elon Musk, account number, and the balance. Yeah, and I keep hitting it. Sorry. So that's what our sample code does. It creates spaces in memory, it creates variables. All of the, everything is in our main. So it's all, we're dumping all that code into the one place. And remember at the start we were saying that that's the equivalent of having one person in an organization doing everything. So all of the information that's required is in the one place. It's in our main. So what happened if we needed more than one account? So if, you know, Elon Musk's, some of his kids needed accounts as well, what would we have to do based on what we know now, we know so far? So all the accounts would need the same set of variables. They'd all need deposits. All the deposits withdrawals would have the same behaviour. So if we're withdrawn, we have to check to make sure that there's the money there to be withdrawn. If we're depositing money in, we have to make sure, I suppose, that it's between a certain value or it's greater than zero, whatever it is. But they all have the same behaviours. They all have the same variables. So if you think back, we had a name, we had an account number, we had a balance. So all our accounts would have the same information. But all would need to be completely rewritten with different variable names, different method names. Okay, so if we were to write the code again, just using procedural, it would mean that we'd have to do all of this again for Elon Musk's children or whoever else we want to put in. So we'd have another string name. So it'd be string name 2 equals Joan Musk. String account number 2 equals 1, 2, 3, 4, 5, 6, 7, 8. String balance 2 equals, or double balance 2 equals, and then we'd have to do same code again, or if we want we could put it into a method, but no matter what we were doing, it's all going to be in here. And then we'd have to have another one for another account and another one for another account and so on and so on. And all of a sudden, what looks, you know, fairly simple now is being replicated and duplicated all over the place. So the same code is being written over and over again with just different names, different account numbers, different balance variables, etc. So again, absolutely doable, just doesn't make sense based on what we know. So what we want to do here is we want to create a class. So a class creates a unique data type. Okay, so what that means is that the class that we create, we can create objects based on it. So it's the blueprint for our objects. When we create a class, think carefully about what you want the code to do. What are the attributes? What are the behaviors? Okay, so first we'll start by listing the attributes and figure out what data type they should be. So if you're asked to write a piece of code and you're asked to write a piece of code around a bank account, okay, how I start is I start maybe with the name, and then I write all the information I need to store. So I might need to store the name on the account. I might need to store the number on the account, that is an M. I might need to store the balance on the account. I might need to store an overdraft if we have an overdraft on the account. You might need to store, I don't know, some sort of an interest rate if that's what we're going to have. Okay, so you write down all of the information that you need to store. And then you come back and you say, okay, well, a name, that's going to be a string. A number, it might be a string because it has a 0 at the start. It might be an int, but it depends. We'll analyze this number and see what the number is made up of. It might have alphanumeric fields. Okay, so it might be a string. But again, we'll look at that. The balance might be a double. The overdraft facility might be a yes, no, or a true, false. So it might be a Boolean. The interest rate might be a double. So we start off by identifying what information that we need to store. So that's going to be our fields, and figuring out what data types they are. Okay. So if we look at what we're looking at here, what fields do we need to model the bank account? So the fields are the attributes or the information that we need to store. So if we're looking at this example here, we're going to look at what information do we need to store. So again, we need to store the name, we need to store the account number, and we need to store the balance. So they're the fields that we're going to need to store for our bank account. So we identify our fields. So again, the string name, string account, and the balance. When we're creating our class, we have to give our class a name. So the name of the class should be carefully considered and it should match its purpose. So it should, a bit like our Ronseal can, it should do as it says on the tin. Okay, so it can be any word or words. It should always begin with a capital letter, and that's so important. Your code will work no matter whether you begin it with a capital letter or not. But it's good coding practice to always give your classes a capital letter. Okay, so it should always begin with a capital letter. It should not be pluralized. So what that means, it's not books, it's book. It's not cars, it's car. You'll create many cars from the car class, but it's the class name is the noun and it's singular. Okay, so for our first class we can use names like bank account, student, product, etc. Again, we're creating a bank account, so we're keeping the name in line with what it does. It's a bank account. And again, you'll see we're using camel case. So where we have another word inside, we're capitalizing that. Okay. So capital B for bank, capital A for account. So we're going to call our first class bank account. So again, this was your version 1. This is before we knew how amazing classes were. We dumped everything into main, and really it's not going to scale up. It's going to be only good for one person, and that's this guy here. It's only going to be good for one person. So this is where we threw everything into main, and we had only our one person. If we wanted to add in more accounts, it wasn't really going to work. So now we're starting to write a class, and we're going to be able to access that class. So we're going to create this class called bank account. In our bank account, we're going to have the fields, the information that we need to store for that bank account. So remember we said we needed to store the name of the account, the balance, and the account number. Okay. In this case here, in our main, we're going to create our bank account. We're going to give the name Elon Musk. We're going to create the account number, and we're going to give it an initial value of 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to create the balance. In our bank account, we have a balance, a field called balance, and we're going to give it an initial value of 1,500. Okay, so this bank account object, which exists in memory, has a name for Elon Musk, and it has an account number. So let's have a look at what's happening there. So in memory, we're creating an object called bank account 1. And that's pointing to this object here, which has a name. It has an account number. And it has a balance. Into our name, we're putting Elon Musk. Into our account number, we're putting 1, 2, 3, 4, 5, 6, 7, 8, 9. And into our balance, we're putting 1,500. Okay, so now we have one space in memory. In that, it has a name, account number, and balance, and it's all referenced by our bank account. And in the last set of slides, we talked about the dot operator. Here you can see the dot operator in work. So it's bank account dot account number, bank account 1 dot balance. So you're saying the make the name of the object bank account 1 equal to Elon Musk. Make the account number of the object bank account 1 equal to 1, 2, 3, 4, 5. Make the balance field of our object equal to 1,500. So in memory, we're creating an object called bank account 1, and it will have the fields, a name, account number, balance, and we're giving them values. So when you go to write this, your bank account is going to be one class in IntelliJ, and then you'll have, in this case here, we'll have some sort of a driver or a main, whatever we want to call it, and in this we're going to just have another main. We will write this slightly different as time goes on, but for the moment we're just putting this into main. So we have our bank account class, and we're creating objects, we're creating instances of that bank account class. So we define the class bank account, and we create our fields. So I'm just going to quickly, where are we? We have a lot to do. So I'm just going to quickly show you how to do this. I think it does come up in our notes, but just so we just create a bank account project. Okay, in our source folder, we're going to create a new Java class, and we're going to call it bank account. Oops. Do as I say. So capital A for bank account. So here we'll have our class bank account. Into this, we're going to create our field for name. We're going to create a string for the account number. And we're going to create a double for the balance. Okay, so this is going to be our fields. And then when we want to add behavior, we're going to add to our we're going to add methods. but this here are our fields. So this is the data. Okay, so this is the information that we want to store for every bank account. Okay, and we'll get to methods in a while. So this is where we define the class. And remember, in IntelliJ, it's very important that your class name is the same as your file name. Okay, so we give it a name that makes sense. We declare the fields in the class. So this is where we have identified the data that we want to store about every object, and we say what data type it is. So we have a name, which is going to be a string, an account number is going to be a string, and a balance. And you can see in IntelliJ, we place this code in a new Java class called bank account. So you can see that that's what we've done here. We've created our bank account class, and into that we've added in the fields that we're going to store for each one. Okay. So this here is our bank account, and this is the class, our driver class, that's going to use that. Okay. So we're creating an instance of that bank account, and we're going to give it information. So when we want to declare an object, so we want to create that space in memory that's going to store our object, we use a special way of doing it. So remember how we create, if we wanted to create an integer, we would say, so we wanted to create a space in memory called num. We'd say int num equals 5 or whatever it is. And this is where we would declare the space in memory. And here's where we initialize it. We give it a value. We're kind of doing the same thing here when we create an instance of an object. So when we create an instance of the object, this is like your data type. And remember a few slides ago we said when we create classes, it creates a unique data type. So here we said int num. When we're using a class, we have the class and then the object name. So in this case, it's bank account 1. So that's the same thing. We've created a space in memory called num, and it's going to store an int. Here we're going to have an object called bank account 1, and it's going to store a bank account. When we say num equals 5 is when we put the number 5 into the space in memory. When we say bank account 1 equals this new keyword, new bank account. So that's what's happening here, equals new bank account. That's when we're creating the space in memory and initializing the values. Now, this is called a constructor, and we'll get to that in a second. We haven't created one of those in our bank account yet, so Java by default creates a constructor which will give name, which will put initial values into our balance. So it'll have a balance of 0 and null for name and account number. Okay, so here up until now you've been creating your variables, and you've just said data type variable name. For a class, we're saying class type object name. When we want to give it a value, we give it a value. Here we're creating the space in memory, and if we want to access one of the values, one of the fields, we're using our dot. So we're saying object name dot name, and that should be an equals there. Sorry, there's a missing equals. So that should say bank account 1 dot name equals Elon Musk. bank account 1 dot account number equals 12345, bank account 1 dot balance equals 1500. This is where we're putting the values into the fields. Okay, and again, we haven't changed much here. We're saying if the bank account 1 dot balance is greater than the withdrawal amount. So again, our logic is still in this version 1. We're not going to look at changing the behavior today. We're going to look at that on Wednesday. But you can see here we're starting to place our logic here, our data into our bank account. Okay. So when we call the constructor, so we call the bank account constructor, that's when we use our new keyword. This is when we're building our space and memory. So again, we have said before, until you create the object doesn't exist. Our new keyword is what we use to create our object. Okay, so you'll be seeing this quite a lot, our new keyword. So we initialize the fields in bank account with starting values. Now we'll see a better way of doing that as we get better, and we might do it through our constructor. And we'll also see a better way of accessing our fields as we go on. We won't access them directly. Okay. So we use the dot with the fields in the bank account in the assignment statements. So we're saying the name of bank account 1, make it equal to Elon Musk. The account number of bank account 1, make it equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. The balance of bank account 1, make it equal to 1500. Okay, and again, just to keep looking at the dot, and that is how we identify the objects field or the objects method. Okay, so a constructor is a piece of code that we write. And it constructs the object. So when we call that new, when we use new, it's calling the constructor. So when we say bank account, so that's our class, and this is our object, it creates a space in memory called bank account 1. And at the moment it's pointing to nothing because we haven't called the new keyword to construct that bank account. So we've declared an object and we've initialized it to null because we haven't built it. We haven't called the new keyword to construct it yet. When we call the new bank account, it calls the constructor, and at that stage the memory is allocated, and if it doesn't initialize them to Elon Musk unless we tell it, but it does whatever the constructor tells it to do. So it creates a space in memory, it calls it bank account, so we can hear, and we have a name, the account number, and our balance. Okay, so this is what's being created. So our new keyword calls the constructor. We're going to learn to write the constructors in a little bit, but a constructor is a special method that has the exact same name as the class, and we call it when we are building the object. Okay, so in this case here, it's constructed with the keyword new. So you can see here we're creating our object and then we're constructing it by calling the bank account method. So bank account is the default constructor that's called to build the object in memory. A constructor is a method that has the same name as the class but no return type. Okay, so if we don't create a constructor in our code, Java has one by default, but we will start to create our own as time goes on. So a constructor is the code that's required to construct the object. So that might mean giving it initial values, and it's called by calling the new keyword. Okay, so this is the default constructor. We don't need to create a default one if we don't create any other ones. Java will automatically have a default one, but we might want to give name an initial value. We might want to give an account number initial value. We might want to give the balance an initial value. So if you don't include the constructor in your class, the compiler inserts one and you won't see it in your code. Okay. So we have our constructor here, and you can see here that when we create it, name will have null in it, bank account number has null, balance has none, because we haven't given it any construction details. So by default, that's what Java does. If we don't tell it what to do, Java gives all strings the null value and all numbers the 0 value. Okay, so we said here that constructors store initial values in the fields of the object, and they often receive external parameters for this. Okay, I'm actually going to stop there. I'm going to stop here on our constructors because there's quite a lot of understanding as regards parameters when we're passing our constructor information. So I don't want to rush through it and for it not to be not to make sense. So on Wednesday, when we're going through our methods, I'll go through the parameters again. But for today, let me see. What I want you to look at is creating the fields and having a look here at your default constructor. Let's say, for example, we wanted, I'll do it in the code. So in here, if I want to create the constructor, so remember what the constructor is. It's a public method that doesn't have a return type, and it has the same name as our class. If I don't write any code in there, by default, our name will have null, our account number will have null, and our balance. But let's say I wanted to create, when I create my objects, I wanted to have an initial value. So when I construct, the name might say unknown. The account number might be all zeros, and the balance might be 0. So if I wanted to, when I construct my bank account object, when it's constructed in memory, instead of having null, null, and 0, if we use my code here, when it's constructed, it will have unknown for name, okay. So now when I construct my object, it will have these initial values. So that's my default constructor. So my default constructor, if I don't write anything, Java will create its own default constructor, and it will give the values null to strings and then zeros to numbers. Or I can create my own constructor and I can give it my own initial values at the start. So every time a new object is created, it'll have its own initial values. Okay, so I think I'm going to leave it there because the next step is to show you how to create an object and to pass it information. So we've been passing information in our methods by parameters, and so we're going to show you, how to, what we call overloading. It's when we write the same method name, but our parameter list is different. So what we're going to do is, for our bank account, we might have a default one which gives us our initial, unknown 000 default values. And then we have another one where we pass it the information it needs to create the account. So again, when our object is constructed in memory, it's constructed with information that it requires. So we'll have a look at the parameters on Wednesday, because there's quite a lot in it today, and we don't want to really confuse matters too much. So if we're going to use this, and I am going to leave you, I promise, if this was our class, our bank account, and we said new Java class, if we had our driver, so you can see here that this is our main. At the moment, our bank account is grayed out. If we want to create a bank account, we'd say bank account, and we're just going to say BA1 equals new bank account. So that's where our bank account object is being created. It's going to be created in this case with those values. So when we called new, it calls this constructor, it creates it with those values there. And if we were to say at this stage now, BA1 dot name, okay, so if we run that now, you can see that it has the name unknown, because when it was constructed, it used this values here. And if I go back in here now and I say BA1 dot name equals, and we'll use our old Elon Musk. And we print it out. You can see it was first unknown because that's that line there. Then we used our dot notation and we said for the name of the object BA1, put in Elon Musk, and then we print it out. So now in that space in memory, it's storing Elon Musk. So for the next day, I want you to have a look at what we've done today from creating a bank account. Most important that you understand that the class is the blueprint. The code, how it works, that's going to come to you. It's the idea and the logic behind what it is that we're trying to do, that we're trying to create this self-contained classes, and in that class it's going to have all of the code that's going to do what you want it to do, and you can call upon it a number of times, so you're not writing the code over and over again. And think back to our first example where we had all of the code in main, and when we wanted to create new accounts, we're going to have to create new variables, whereas when we put it into a class, now we just create another object, and that object is going to have a name, an ID, and a balance, and so forth. And we'll play with that on the next day. So for the next day, we'll start off with the constructors and start off with the parameterized constructors. All right. Going to leave it there. I'm way over time. I'm really sorry, and I'll talk to you on Pete will be on tonight, and I'll talk to you on Wednesday. Okay, bye bye.